All righty. Hello, everyone. Section 2.4 today, statistics. A little bit of warning on this one. This one might be a tad longer also. There's kind of a lot to go through. I would say this right now is the most important section we've had so far. It's the basic introduction to the normal curve. We're going to come back and study the normal curve really in depth later on, but this is kind of the beginning of the rest of the class per se. The normal curve is what all of statistics is based on. All of what we do is based on. So getting an understanding of how it works first is pretty important. So the basic idea here, if you look at my chart, is that we're going to look at a normal curve. It's very common in the real world for data to fall in this shape. When you have a lot of data, like IQs and SATs and PSATs and test scores and things like that, a lot of times they fall heights, weights, they kind of fall in this pretty rough normal curve shape. And the nice thing about a normal curve is it has properties. So this is what's called an unknown percent problem. If you look there, is that we want to know what percent of the data is underneath or to the left or to the right or in between two numbers on a normal curve. So this is just a pretty rough normal curve. Sorry, it's kind of small, I know. That has a mean of 1,050. My information's over here, and a standard deviation of 150. So this is the mean, and the standard deviation is 150. Standard deviation, we're using SD. Sometimes we use S. Sometimes we use sigma. Those are all variables we use for standard deviation. So the question might be on this one, like what percent of the data, you can see my question, scored 900 or below? Or if you think about it as a percentile question, the person who got 900, what was their percentile on this test? The person who got 1,050, that percentile would be 50%, right? So we're looking for this area here, in essence, is what we're looking for. Okay. So what we're going to do today is kind of learn how to find that area depending on the number. But you can see it would be a little complicated with different curves and different means and different standard deviations. However, it's really not, because watch. Let's say I take this mean. So forget about these numbers here. All right. Let's say my new mean was 200. And let's say my new standard deviation was 10. Okay. So the original question, let me go back to it just so you can see it, was let me change my colors there. What percent's to the left of 900? Notice that 900 is one standard deviation away from the mean. Okay. So the mean's 1,050 with a standard deviation of 150. So 900 is one standard deviation away from the mean. If we go to my other picture here with the other color, and I have a new problem, I'm just going to write it here, that has a mean of 200 and a standard deviation of 10. If I ask you what percent is to the left of 190, seems like a completely different question, but it's actually the exact same question, because notice in both the purple graph and the orange graph that the number that our cutoff is one standard deviation from the mean. So if you go to one standard deviation from the mean in any normal curve, it's going to be the same area. So what we have to do is figure out how to deal with that then, right? So here's what we do. So what's really important is how many standard deviations away from the mean a number is. That becomes the important idea. Okay, so I know that's a little small, sorry. So the idea there is, since all normal distributions are similar, we can do what's called recentering and rescaling to make our life a little bit easier. So I'm going to introduce you to what's called a standard normal curve. And what we're going to do is study the standard normal curve in depth to be able to answer our other questions. So in a standard normal curve, the mean is 0, and the standard deviation is 1. Okay, standard deviation is 1. So again, if I said what percent of the data is to the left of -1 in that curve, it would be the exact same answer as it was in the two above it, because they're all just one standard deviation to the left of the mean. All right, so we're going to introduce you to this term called a z-score. A z-score is how many standard deviations away from a mean a number is. Okay, here's your formula for z-score. You're going to hear that term z-score thousands of times in this class. Super important concept. It's how many standard deviations away from a mean a number is. It could be positive or negative. Positive, means to the right of the mean. negative means to the left. All right. So what we're going to do is I'm going to ask a question like, what percent of the data, we'll go ahead and answer this question, what percent of the data is to the left of -1? I circled 1.23 here. We could do any number for the z-scores. And then what we're going to do is we're going to translate that back to my other question. So we have a chart in the back of our book. It's also on your note sheet that really is going to help us with this. So it's on page 699 or 700. Sorry, 699 and 700 in the back of your book. It's also on your note sheet. I'm going to grab the note sheet out right now. We're not going to write that. Here's the note sheet. And I'm going to go through all the notes. And then right here, these 2 pages are the same as this page 699 and 700 in your book. And these are what are called a table of z-scores and their area to the left of the z-scores. So notice what we have here is a standard normal curve, mean of 0, standard deviation of 1, and some z-score. And we're going to look to find the area to the left of that z-score, right? So if we want to use the one we were using before, remember that z-score was -1. This table, here's how you read this table. I know this is a little bit harder not being in class here. These numbers on the left here are the negative z-scores. If you go to the next one, next screen, these numbers here on the left are the positive z-scores, okay? And then inside the chart are the areas to the left. However, there's lots of different numbers. So I'm going to just circle a number right here. Hopefully you can follow that. And notice that that number, let me blow it up just a little bit, is on the -2.1 row. However, it's in the column of 0.04. So that number actually corresponds to -2.14. So this number right here, let me change color so you can see it, sorry. This number right here is -2.10, okay? -2.11, -2.12, 2.13, 2.14, and so on. And it always tells you the area to the left, okay? If I ask you what the area to the right is, you're going to have to take the area to the left and subtract it from 1. Okay? So I'm just going to do some example problems for you. I'm going to bounce back and forth from that note sheet to this. So these are the types of questions you would get. Okay, you can get asked. I'm going to just ignore this last one. We don't want to do that one right now. So the first question is, what percent is below 1.23? So I'm going to go to my chart. Sorry about this. I got to bounce back and forth. 1.23. I come to this side. There's my 1.2. There's the 1.23, 89.07%. So we go back here, and this is 89.07%. Okay. What percent is between -1 and 1? Anytime you're asked between or to the right, you just have to do a little fudging per se, because this only tells you to the left, right? So if we go to the left of -1, so right now I'm looking between -1 and 1, right? So what I'm going to do is I'm going to find this area on my chart, which is -1.00, which is this number right here. So that's 15.87%. So there's a couple ways to do this. Because there's symmetry in this one over here has to be 15.87% also. Could add those two up, about 31-ish%, right? And then subtract from 1. The other way to do it, if this number wasn't 1, let's say if I asked between -1 and 2, you just find, let me change the color here so you can see it. You would just find this area here to the left of that one, right? And then you just take the green area and subtract the orange area, and it would give you the area between those two. I know this is pretty quick, so you're going to have to ask questions in class. Practice this. It's super important. But I don't want to be on here too long. And then we could go the other way. Notice this. Find the z-score that goes along with 75% of the data. All right. So we come back here to the note sheet. And now what we're going to do is we're going to go inside the chart. Let me do a little bit of erasing here. So this is not all on your way here. What we're going to do now is look for 75% in here. Okay, so we come in here, so we're looking for 75%. I'm kind of just looking, sorry, I know you can't see this, 73.578942. So right somewhere between here and here, okay, is that number. If you don't get an exact number, so 75%, so we're just kind of estimate right now. So I would estimate just right in the middle. Just go to the middle. You don't have to worry too much. I would probably take any answer. But notice it's 0.6, and then we come over here, 0.67, 0.68. So it's between 0.67 and 0.68. So we could just probably say 0.675 is the z-score for that. So here's the thing. The numbers on the outside are z-scores. The numbers on the inside are the areas to the left. Okay, we're going to do some more examples. Don't worry. This curve only works for a mean of 0, standard deviation of 1. So now we got to talk about what happens when the mean's not 0 and the standard deviation is not 1. And that's why z-scores are so important. Okay. So standardizing is called a process, two-step process that turns any normal distribution into a standard normal distribution. What's important is very simple. Okay, it all comes down to how many z-scores is away, how many standard deviations away from a mean is a number. So we call this a z-score. It's called a standard unit. It's the way you find it is you take the number x, you subtract the mean, and you divide by the standard deviation. The ones we did earlier were very easy because it was one standard deviation, so it might be 1.2 or 1.3. So we'll definitely have some examples here in just a second. But you just want to figure out how many standard deviations away from the mean it is. So you figure out how far it is, and then you divide it by the standard deviation. How far is it from the mean? Positive or negative, super important also, okay? So here's a quick example, and we could do look at the chart afterwards. It just says find the z-score for 900 if the mean is 1,055 and the standard deviation is 200. So the z-score is very simple. It's just the number 900 minus the 1,055 divided by the standard deviation, which is 20. I got a little calculator here. Go 90 minus 1,055 and divided by 20. Oh, that didn't work. Let me try it again. 900 minus 1,055 divided by 20, and I get, whoa, that didn't work either. Did it work? 900. I have the right numbers there. 900. Oh, the standard deviation is 200. You were all laughing at me right there going, oh, the reason I knew I was wrong is the z-score was way too big. Okay. That's how I knew it was wrong. You usually don't get z-scores more than 2 or 3. Almost all of the data is within 3 standard deviations of the mean, which I'm going to talk about in just a second. So that's how I knew that I didn't have the right one. 900 minus 1,055 divided by 200. There we go. Negative 0.775. And then I could look in the chart to see what areas to the left or to the right or whatever asked, which we'll do in just a second with a real question. You can unstandardize a number. You can work backwards. If you get the z-score, right, it's just a mathematical formula, right? So we get z, I'll come down here, equals x minus x bar over the standard deviation, right? So you can always work backwards just by doing some algebra. Just remember this formula. It's actually on your note sheet also. Just remember that formula. But no matter what information I can give you, if I give you the z-score and the mean and standard deviation, you just solve a little algebra equation, right? Okay. Hopefully you can handle that. So let's just do an example here. I don't want to do too many because I know. So these are what the questions look like. So we're going to start with, we got normal distribution. I always like to draw a picture of these. They help a lot with a mean of 70.1 and a standard deviation of 2.7. And then really simple question right here is what percent of the data is greater than 74? What percent of the data is greater than 74? So what I'm looking for is that area right there. Pictures, super important. Draw them. They're very, very helpful. Okay. So I'll walk you through this problem. So what you do is you find the z-score. Remember that the z-score is what's important because that's what the back of the book is telling us for mean of 0, standard deviation of 1. So the z-score is 74 minus 70.1 divided by 2.7. I do that on my calculator. 74 minus 70.1 divided by 2.7 gives me 1.44. I'm going to have a little bit of rounding issues going on here in just a second. I'll explain that. 1.44. All right. Now I'm going to go to the chart, which is really, really messy right now. So let me get all that out of here. So we're looking for 1.44. So again, here's 1.4, here's 1.4. But remember, I'm looking for 1.444, right? So this is 1.44, this is 1.45. So what we really do is just go right to the middle again. All right, so just find the average of those two numbers, 0.9251. It's just a little estimate. We'll have a better way to do this a little bit later. 0.9265 divided by 2, I get 0.9258. 0.9258. Now, what does that represent? We go back to the problem. 0.9258. Remember that chart only does to the left. So this is the 0.9258. But that's not what I was looking for, right? I was looking at the area to the right. So I'm just going to subtract that from 1. And I'm going to get 7.42%. Okay. That's the percent of the data that's to the right of 74. And now I'll just go the other way also. The next question is, what height separates the shortest 75% from the tallest 75%? So I'm going to redraw this curve. Same mean, right? 70.1, 2.7. Now we want to cut off the 75%, right? So this is 75% and this is 25%. So now what I'm going to do is I'm going to go to that chart and look for that z-score that goes along with this cutoff. So I go back to the chart. I'm looking for 75% again, which was the one I think we did before, right? It's right here in the green. It's right between 0.67 and 0.68. So we're going to call it that 0.675 again. Remember, this is the area inside the charts, the area outside the charts, the z-score. So now we're going to go back and we're going to say the z-score is 0.645. Uh-oh, is that the right number or is it 0.675? Sorry. Oh, good. It's 0.675. 0.675. That has to be equal to the number that we're looking for, which is x minus the mean divided by the standard deviation. Now it's just an algebra equation. By the way, this is the hardest math you will do in this class. Just solving a little equation. We're going to go 0.675 times 2.7. We're going to add 70.1 to it, and we're going to get roughly 71.9. So that's the cutoff that cuts off the lowest 75% from the highest 25%. So that's a couple examples. I know it's not a lot. I have one last thing I want to show you here, but no more examples of this. You might want to rewind this and see it again if you need to. All right, just the last couple things. There's things that are called central intervals, which are numbers that we should probably just kind of recognize all the time. And it's 1 standard deviation away from the mean, 2 standard deviations away, 3 standard deviations away from the mean. So we often say that there's roughly 2/3 of the data within 1 standard deviation of the mean. But it's not really 2/3. It's actually, if you look at the chart, you can figure this out. It's actually about 68%. So, but the book a lot of times is just going to say roughly. I don't want you to do roughly. I want you to go ahead and use that chart. Roughly 95% of the data is within 2 standard deviations of the mean. And almost all the data, 99.5%, is within 3 standard deviations of the mean. It's very unusual and normal curve to get further than that. Sometimes we do. They're like outliers. So. And then working the other direction, these are numbers we're going to use all year long. I don't expect that you would memorize them at the beginning, but it's worth memorizing. We do these things called central intervals. 90% of the data, the z-scores that go along with 90% of the data in the middle, not to the left or to the right. Remember, the chart's just to the left. But in the middle is 1.645 and negative 1.645. This is the most common z-score in the world. We're going to use it 1,000 times this class. 95% of the data in the middle, those z-scores are 1.96, roughly 2, right? Remember up at the beginning, I said about 95% of the data is within 2. It's not exact. So those numbers, 1.96, are super important, but you can look them up in the chart, so you don't have to memorize them. And then, I don't have the third one on there. Sorry. Let me put the third one on there for you. It's 99%. So these numbers, it's negative 2.575 and 2.575. These numbers come up a lot. The 99%, 95%, 90%, they're called confidence intervals. If you've heard of confidence intervals, or hypothesis testing. So we use those numbers a lot. So we just kind of introduce them to you right now. So I know that was a long lesson. Sorry. Try your best. We'll go over lots of problems, get some help. Ask me if you can't understand. I can do another video for you. But this idea of learning that normal curve is massively important in this class. So let me know if you need any help.